Hello, this is Larry with the ABA Engineering Academy, and we want to welcome everybody to our first engineering webinar for 2021. We actually started these webinars back about the middle of last year, and we've had very good attendance and had some very good presenters come on to be with us during 2020, and we're going to continue to do that as we go along. This webinar series is actually part of the Engineering Academy at the Alabama Broadcasters Association, and it's produced in association with the Georgia and the South Carolina um, associations as well. We want to thank all the state broadcast associations around the country because a lot of them have joined up with us and promoted it in their actual newsletter. And that's really helped quite a bit to get everything going and get more people on. Our actually corporate sponsor, we have a corporate sponsor that helps us. So that's Bond Broadcast Services. They are a full service company. They sell equipment and they also have a service department. So if you have any need for any of the any equipment from microphones all the way up to the antenna, or if you need any service on any of your equipment, be sure to give them a call. We want to mention just a couple of housekeeping notes here that we ask, if you will, to please keep your microphone and your videos muted. That helps the clutter and it also helps to on bandwidth. Sometimes we can end up with a bandwidth problem if we have too many videos coming up. So if you'll do that, we would appreciate it. If there's any questions that you would like to ask our presenter or anybody on the presentation today, you can use the chat. You can just click on the little chat unit either down at the bottom or the top of your screen, depending on which type of system you're using, and just click on chat, and you can type it in, and our guest will see it, and he can answer the questions for you. Before we actually jump right in, I want to mention a couple of upcoming programs. Some of you sometime will actually have to drop off early. So we've got one coming up next month, February 16th, with John Myatt. John is with Imagine Communications, and he has been very much involved with SMPTE in developing the ST 2110 standard. This is a new standard for television to actually be able to send audio, video, ancillary data, and other information over IP. And he's very well versed in that. He's very people always ask him to speak at these different conventions, and we were very happy to have him join us next month. So make sure, if you're in television, make sure you make a note of that date, February 16th. And if you have any friends that are in television, remind them as well. Our March, we'll go ahead and mention March while we've got you stopped here. This young fellow sitting here with all the beard, that's not me. I did shave this morning. That's Andrew Shep. Andrew Shep is one of the top ranking mix engineers in the country. And he's worked with a lot of different artists from Red Hot Chili Peppers to Metallica to a guy named Michael Jackson. He did a bunch of stuff with that. Andrew is going to join Frank Fody, and we're going to talk about radio production. And Andrew has a lot of good information about since we changed over from analog to digital and using digital audio workstations. A lot of his information is geared toward music production. However, they also apply for radio stations as well. And so we're very happy to have him signed up. He's actually over in London, but he's going to join us if we can get Zoom to work all the way to London. But he will be with us along with Frank Fody. That's on March 16th. I want to introduce our co-host today, John George. John was sort of missing, I think, last month. He told us he was working somewhere, and so I'll just take his word for it. And and John, welcome back to us. And you have a special guest, I think. Ready
Well, we
for
certainly do, and thank you, Larry. And we welcome everyone here in attendance right now. We're up over 50, I think 55 in attendance, which is one of our largest meetings that we've had. And also a special welcome to Bert Goldman, our speaker. I've known Bert for a long time, and he's a very knowledgeable engineer and has been on the cutting edge of a lot of technology in the industry. Bert's currently the president of Goldman Engineering Management. He brings more than 40 years of experience and specializes in AM/FM spectrum for the purpose of improving facility coverage as well as all facets of construction. Bert has directly managed the engineering efforts as corporate vice president of engineering for ABC Disney, Nationwide Communications, Patterson Broadcasting, and Shamrock, just to name a few. During his career, Bert has engineered numerous station improvement projects, including stations in most of the top 25 markets. Bert has extensive experience in the latest FM single frequency network design, which he'll be talking about today, and in implementation, and he has participated in experimental testing of the geo-targeted SFN single frequency network operation, which I think many of you will find quite interesting. Bert is a member of IEEE, the SBE, associate member of the AFSI. Bert's also been active in the broadcast industry, including the NAB, NRSC, National Radio Technical Committee, and has written several articles for the industry trade press. I now introduce Bert Goldman. It's all yours, Bert, and welcome.
Hello there. Thanks very much. I've got a PowerPoint to share here, and I'm going to do that right now. I'm hoping everybody can see that.
Yeah, we got it good.
Okay, good. Very good. All right, well, it's great to be here, everybody. Today we're going to talk about two things, max casting and zone casting, which are trade names for two different types of single frequency networks. Max casting transmits the exact same synchronized audio over all the main and all boosters, booster or boosters. And zone casting takes max casting one step farther, and in certain locations where the boosters are actually for a very limited period of a broadcast hour, transmits slightly different information. So let's get started on there we go, on boosters in general. A lot of you folks, especially in the flatlands there on the East Coast, haven't messed around with boosters too much. A lot of us out in California have been beating on them for years trying to get them to work. But the rules as they stand currently with the FCC is the booster, of course, has to be on the same frequency as the main transmitter. Primary contour cannot be extended. It's a secondary status facility which can't cause interference to any other stations. Limited interference is allowed within the primary coverage area of the station, except there cannot be interference in the community of license. It may also operate at any height, but cannot operate with more than 20% of the maximum class power, for instance, 10 kilowatts for a class B. And of course, it still has to maintain the primary contour. So whatever power works to make that happen within 20%. And you can feed them in any manner. We're using IP for everything that we're doing, which I'll get into. But of course, you must have positive control of the transmitter. So the modern booster design, back when the commission deregulated boosters in 1988, I believe it was, there wasn't a whole lot known about how to make these things work properly. So what we've determined over the years is that the things necessary to get boosters to operate without causing a train wreck, you have to have the carrier and pilot GPS locked. We use the Synchrocast system to lock those with GPS. Pilot phase has to be matched and matched in the exciter based on the delay. That's not an issue if you use digital composite. modulation must be matched within a quarter of a dB, which is a pretty tight tolerance. Again, if you use digital composite, that's not an issue. It's also possible to do it with regular AES, but you have to be very careful about setting them up and making sure that they're working properly. Timing, you have to set it up so that the propagation matches. We use Synchronization for that. I believe that's one of the few ways that you can make that work across an IP network. Synchronization has to be stable within 3 microseconds, which is an extremely tight tolerance that, quite honestly, most of us in broadcasting aren't used to that kind of stability. The antenna has to be chosen to reduce the delay spread. We'll get into that in a few moments. And we now have the ability to do HDSFN after an awful lot of lab work to make it work properly. It works great on paper. It's just making it actually work in the field. So one of the things that we worked on when we first decided to come up with the parameters to make boosters properly synchronized, we realized there was no subjective standard on what people will actually put up with, excuse me, as far as interference goes between the main and the booster. So Geo Broadcast commissioned a study by NPR Labs and used 19,000 audio samples evaluated by 80 listeners. They did a subjective analysis of various impairments and graded those. And based on that, we came up with keep-on scores. I'm pointing to the 90% keep-on, which is our target for all max casting systems. Sometimes we can't keep that over the entire coverage area. Most of the time we do, however, but that's that has proven itself quite well in the field, that keeping it in the 90% range makes for an incredibly good sounding facility. So, of course, to come up with these things, we have to have very precise information on what the RF levels are. We use a very expensive propagation software called ATDI ICS Telecom. The software uses a propagation model of ITU 525, 526 with Daegu diffraction. That seems to work very well for what we're doing. And we also tune it using the Automat MC5. We drive a market. In fact, I just drove San Jose, California 3 days ago. But we correlate them, and I'm not sure how well you can see this. You've got the yellow and the green. And after we tune it and input the information, this is how well the two correlate. It's extremely tight correlation between the propagation model and the actual measured signal. So now let's look at what happens if we put all this stuff together. This is what would happen in Chicago if we put a booster on with a non-directional antenna, even though it's synchronized. The magenta is interference. And as you can see, that would be quite a train wreck. That's not what we're shooting for. Even though you cover Chicago, that'd be okay. But obviously that's not gonna work. So using all of our other techniques, besides just the time synchronization, and especially using the antennas that we use, which are dual log periodic antennas, if we orient the antenna 180 degrees approximately from the main, we're able to get perfect synchronization. The timing excursion doesn't go more than about 3 to 5 microseconds. And as you can see, we're able to keep really good quality driving into and out of the booster. The only problem is that you're only covering a fairly small area, but we'll get into that in just a moment. So if you try to increase the power so that you can cover more area, If you increase it too much, this is a 15 dB boost over what you just saw, you get a bloom of interference along the edges here. We certainly don't want that. If you depart from 180-degree orientation, you get blooms in one degree or the other. If you don't have the timing right, optimum was 90. This is at 78 microseconds. You can see interference. And this is at 100 microseconds. So this is only 10 microseconds off of ideal. And you're starting to see interference come up here, which is why we say that, you know, the tolerance have to be kept very tight. So rather than increase power and change the orientation of the antenna, what we do is we add additional nodes and additional boosters. And this is how we achieve that. So we can still cover a fairly large area, but we have to add additional transmitters, antennas, and such. It can get a little expensive, but to properly cover a major metropolitan area, it pays off quite nicely. So the nuts and bolts of what we're using, we have dual log periodic antennas. We rotate them 30 degrees for slant polarization. We found that we usually can't go much more than that because if we do, if we do go more than that, then we tend to lose the front to back ratio. So we have to keep that tight. We use a high capacity IP microwave, 3 to 5 megabits for digital composite, low latency. If you want to do HD on the boosters, you have to have a little extra bandwidth for the E2X. We're using the Gates Air IP link system with Synchroncast. We've standardized on the IPXP digital composite for the analog. And we've modified the IP links to carry the E2X with timing controls as well. So that's worked out nicely. The exciters that you're using and the exciter software versions that you're using have to match identically. This is extremely critical because different exciters and different software, even within the same exciter, can change the propagation time through the exciter and can change the modulation characteristics slightly, which could cause problems for keeping everything synchronized. We currently have used these on Gates Air and Nautel exciters. There's no reason why other exciters won't work if they're matched perfectly, but these are the ones that we're using currently. We now have HD, as I mentioned, operational either with the main and analog boosters, which interestingly is more difficult to implement than all HD because of the crazy timing differences that you get through the HD exciter. And we're doing HD boosters at KWFN in San Diego, WKVB, which is EMF in Boston, and I believe we're just about ready to switch on KSBJ in Houston. I think we have all the equipment and they were trying to resolve some IT problems that they have. So let's look at our first max casting system, first successful max casting system, I guess I should say. This is for WXRV, which is about 20 miles north of downtown Boston. Because of where they were, even though the 54 dBu contour didn't get into downtown Boston, or even though the 54 dBu contour, got through Boston, you couldn't really hear it. This map shows the signal without the boosters. The white is essentially no signal at all. The darker the blue gets is, as the signal gets worse, you can see on the scale on the bottom. So we add these boosters, and in this case, we have 5 max casting nodes. And this was also the first time that we put what we call a node within a node. We have a low power node on the Hancock, but we also had an issue with coverage up a little farther north and we couldn't adjust the antenna to do that without causing interference. So we added another node, and it actually works out quite nicely. They're still fully synchronized, and it works great. Signal in downtown Boston is obviously significantly improved. So we're going to go in a little bit about our second Boston facility is WXLO. This is a huge success. Their ratings have, I believe, more than doubled, and their revenue has gone up significantly. I think that may have doubled as well. But even though this was an expensive system, it more than paid for itself. The management there is thrilled. XLO is a cumulus station, which comes in from west of Boston. As you can see here, a very low signal in central Boston. This is the major artery coming into Boston, and there's just nothing there. So we've added these boosters. In this case, we've only added 3. We may be adding more later, but these are doing great right now, and there's enough signal now that the tunnel, the state authority that runs the tunnels said that there's enough signal from WXLO, so they lit them up in the tunnels. So they have full coverage now in Boston, which they didn't have before. And I'm going to give you a close-up of these 2 pictures down below here. So this is what the coverage looks like, and this also shows you the extent of the resolution that we use in our modeling. We actually use the same propagation maps and such that the cellular companies use, which gives you actual reflections off of buildings and coverage down every street. It's extremely detailed, takes forever to run. But what we have here, remember I said the dark blue is bad coverage, and there's pretty much bad coverage everywhere here. Some of it is completely no coverage, like over here around Fenway. So when we add our booster, this is how it lights up. So as you can see, it's a significant improvement. Let me go back and forth for you. So it's a big deal. So obviously the importance of the signal isn't just, we obviously want our listeners to have a better quality experience, but we also want the max casting to improve the Nielsen ratings. The meters can't pick up signal that it can't really hear. So what we've done is we've actually driven the market, recorded the audio, run it through the TVC15 to determine how good the watermark recovery is. And if you can see this map here, this is almost 0 ppm recovery before we put on the boosters, and after it's virtually 100%. So significant improvement, not only in listener experience, but in watermark recovery, and obviously that is a direct impact on ratings. This was an interesting map that we did for the WXLO people. We did a map using some traffic data, because if you just count people using the typical propagation tools that we use, it counts homes. And what we really want is the where people are driving. So this, you can see we're not picking up any traffic in the Boston area prior to max casting. This, for a certain minimum coverage level. After we put max casting on, everything lights up, and it's huge improvement in listenership. So now we're going to go into the West Coast and look at KWFN. This is a slightly different kind of implementation where we have mountains which block the signal, and it makes for some interesting problems. KWFN had a contract with the Padres, and they took it from an AM station, and they drew the 54 dBu contour map, and the Padres said, oh, well, your coverage is just as good as the AM, except when they went out and drove the signal, they said, well, you're not covering out to your 54 dBu. So what's the deal here? So we came in and came up with a max casting solution that filled in their 54 dBu contour. This is what we have built in, excuse me, in San Diego. The first booster node, the signal isn't really terrible here, but the owner of the Padres lives right there. So this is his own personal booster node. And we added these nodes here to cover the areas up on the north side that aren't covered normally. This is our drive test. You can see the dark blue showing how bad the signal was before we put in the nodes. Again, this shows you the vast white areas where there's no signal. And then this is what it looks like when we add the boosters. So it's still not perfect. Nobody lives in here, so we weren't concerned about that. But we picked up Ramona. San Marcos area is a huge improvement, Escondido. And we've been having a heck of a time with the NIMBY folks over here on this west node. We finally, this is Encinitas, we finally have it ready to go, but we can't get anybody out there to tune it because of COVID. So, but this will light up quite nicely very soon here. We also added HD to the KWFN facility. This was the first time that we implemented this. This is the before. HD was not recoverable through this entire area, which is pretty unfortunate. When we added the nodes with the HD, you can see that it's pretty flawless all the way through. So they're much happier with their HD. The Xperi folks are much happier that the listeners have a better experience as well. This is a map of where we've deployed max casting or in the process of deploying. We're using, we have a system 24/7 at KDDS in Seattle. We're about to put a max casting zone casting system on in San Jose, where we have a design and we'll be implementing some things in San Francisco shortly. Los Angeles, San Diego. We did some testing with Cox and Tampa. Our first system on the air was in West Virginia Radio, and of course Boston. And we're doing a design for a large station in New York as well. So beyond max casting, we have zone casting, as I mentioned, for 5% of a broadcast hour. We would define a zoned area and would have slightly different programming. I'll have an example of that shortly, but obviously the modulation can't be synced if we do that. So we design antennas back to back with everything locked except the programming, obviously. And we're able to achieve 16 to 20 dB transition between the main and the zoned area within sometimes a couple hundred feet. So, and I'll show you how that works here in a few minutes. Everything else is still synchronized. It maintains all other booster rules, including interference. The only change that we're asking from the FCC is to make a slight modification to 74123I, which requires identical programming at all times of the main and the booster. We're only asking for 5% separate programming, so it's a pretty benign request, we believe. Comments are due 2/9. It's the FCC unanimously approved the proposed rulemaking. It's been published in the Federal Register, and we would appreciate if anybody would like to make preferably positive comments that you that you do so. The deadline for the first round of comments is February 9th. So to give you an idea of some of the testing we've done, this isn't just, run out in the field and play around with stuff. We have a very sophisticated lab that we've put together where we're doing testing using HD, Rayleigh fading, and a bunch of other things that I'm not involved in the lab, but it's pretty impressive to me. And the improvements that the guys have been able to make in the technology and making the max casting and zone casting systems work flawlessly is pretty darn amazing. To give you an idea, this was the last authorized test that we did in 2017 in Milwaukee. We took WIIL and partitioned it off using several boosters. You can see the border between the zone and the main, and we had different programming running over downtown Milwaukee. They actually wound up getting a nice ratings increase while they had it up. We had to take it down, unfortunately, but they were kind of pleased with what it did, even though it was a test. I'm not sure if you can hear this, but maybe turn up your sound. Last Zoom I did that I did this, it worked. So this is what a transition sounds like. This is driving fairly slowly, I think around 30 miles an hour, starting here and driving this way. And then this is the transition area that you hear.
% off. One general merchandise or apparel. Could be the most expensive night of your life. Getting pulled over for buzz driving could cost you around $10,000.
So I'm not sure if that came through or not, but if it did, that's what it sounds like. I can send you files on this if you didn't hear it or want to hear it again. So this is what we're filing for today. As a matter of fact, the lawyers are scrubbing it down, and this will go. This is our newest request. It's going into the FCC today for experimental operation. This is for KSJO in San Jose, California. This area here is the Pleasanton Livermore area, if you're familiar with the area. Here is the San Francisco Bay Area over here. 400,000 listeners live here. The station format is Bollywood. Nearly 40% of the 400,000 listeners are within their demographic. So they clearly needed a booster in this area. And about 2 years ago, we put one on the air. So this booster is licensed and on the air currently. Does a very nice job of covering Pleasanton and Livermore. But there is a transition between the main and the booster through this area here. It's a pass called Mission Pass. And there are no homes there. The signal dies about here from the main and picks up about here from the booster. So there's a spotty area in there where neither station is actually picked up very well. Here's a view of the Google Earth. We're going to be testing 2 different sites. As you can see, I-680 goes through the pass. There's no homes. There's a few homes up here on the top of the ridge, but they won't be affected by this. And then there's, I think there's a gas station over here and a truck weigh station over here and a horse stable here. So not much out there. So we're going to be adding these nodes, these, as I mentioned, back-to-back nodes. The signal going to the northeast here is going to be the zoned area, which will match up with the existing booster. And then going in this direction This isn't a final drawing, but this will match the main. And because, even though this is going against the main, because of the way the terrain works, we don't believe there'll be any synchronization issues, because once it hits the top of this ridge, the main takes over in strength. So this should be a pretty clean transition with about, we think about 100-yard transition between the two, but considering the fact that there's no audio there at all now, anything's going to be an improvement. This is what it looks like with everything operating, the main, the zone booster, and the transition area. We've done a lot of testing on digital, going from the main to the booster. The San Jose test doesn't really have much of a problem since the HD doesn't overlap, but in places where it does, we've done testing in the lab. And as you can see here, going from the main to the zoned area, we've got the transition down to 1.48 seconds, which is the ALFN boundary for the digital words, basically. We have to do some jockeying to get those to synchronize properly, but once they are, as you can see, it does a pretty darn good job. This is what some of the antennas look like. This is what we typically use. It's a dual log periodic next to each other, makes for a fairly narrow beam, tight front to back. This is used both for the max casting and for the zone casting. This we put in, France is already doing this stuff. They have very narrow patterns on theirs, using 4 logs across. They have thousands of these along the roadways of France, where they transition different road information and different operators of the music and such also get assigned different areas to cover. So kind of an interesting thing. Gates Air sold them a ton of IP equipment. This is what a typical transmitter looks like: fax transmitter, the IP link, and few odds and ends. And that's about it for now.
Bert, talk to us a little bit about what type of programming would a station expect to do in zone casting, and does that add another revenue stream for them?
Well, again, you're only limited to about 3 minutes an hour, but our partners at KSJO in San Jose intend to do a local newscast with sponsored, with sponsored newscast with commercials for the local businesses in Pleasanton and Livermore. They've tried to get advertising in Pleasanton and Livermore, but the people there say, well, your main station is covering San Jose. Nobody's going to come here from San Jose to a pizza place, So, we'd love to work with you, but if it's something that covers our area and is priced accordingly, we'd love to advertise with you. So that's the kind of thing where this works quite nicely. And of course, in the San Francisco area, the weather and the news in San Jose is quite a bit different from both the weather and the news in Pleasanton, Livermore area. So it makes for a really nice example of how these things can be used, and the more ethnic stations seem to be able to use it to their advantage better, because they don't have 5, 6, 7, 8 stations in a market where they can kind of roll off demographics in different areas.
We had a question come up on the chat room about a capital expense. Do you have any thoughts on what we're talking about cost-wise to implement something like this?
Well, we have different models for this. We have a no cash upfront type of thing where it's rolled into an equipment lease with all the licensing, design, construction, and everything. And we're just rolling that out now. But but some stations prefer to just do the capital outlay. Basically, it runs around $50,000 per booster node. Sometimes a little more, sometimes a little less. And then, of course, you've got the operating expenses. If you can share leases, if you have, say, 3 or 4 stations that can use the same tower site, you can get one lease and divide it up to save costs. Same with data. If your IT department allows you to share data with others, otherwise, you have to get your data there. But data costs are coming down in price significantly, and that started off being a fairly big expense, but it's not so big anymore. So you've got your operating costs, you've got your capital costs, and so that's basically what you have to pay for. Geo does have a licensing fee that's not terribly high, but it includes all of this design work and construction and tuning. So which let me tell you, takes a long time. So, and then we also go in and check it out periodically to make sure that the timing hasn't drifted or something hasn't kind of gone sideways that could affect the synchronization.
Another question popped up on the chat room about EAS. How does that play into this?
EAS with max casting is you use the same EAS that you're assigned with the main, because it's the same exact programming. For zoned operation, you're only split 3 minutes an hour. So you can, if there is an emergency, I guess you could postpone the split, or you could rejoin the main, or you could have a separate encoder if you wanted to for the zoned area. But basically, it's just following whatever the main is assigned to at this point. If you wanted to have something separate, it wouldn't be directly under the EAS umbrella. We've had a lot of interest from the emergency notification folks, especially in hurricane areas, that would like to have, if we had a zone in a specific area that's prone to evacuation, then to be able to separately signal those folks from the coverage of the main, perhaps, that don't need to be signaled. So there's been interest in that area in the emergency community.
I know in California with the fire problems they have out there quite often, I would think that would be something that they could use maybe for alerting.
Absolutely. Yeah, and there's nothing that says you couldn't have a separate, separate alert, separate EAS generator for the zoned area, or that you couldn't separate at will to do a specific targeted emergency notification, which I'm sure the commission would allow you to do.
John, you have any questions? Or did John go
No,
to sleep?
I'm sorry, I had myself muted. No, I actually don't have any questions. I find this very fascinating, and obviously, Bert, you've done a really good job on putting everything together. Have you had any? I do have one question I just thought about. Have you had any issues where, especially in flat terrain areas, that it just becomes an impossibility, especially in a metro area, to get the area of interference where you need to have it to cause the least problems?
It's amazing how well it works in the flat area. In fact, my personal experience is it's easier to put together and easier to tune and set up in a flat area than it is in mountains. we had a hell of a time with reflections on KWFN to get all the timing and interference zones squared away. Whereas in Boston for WXLO, we took a drive in a van with Conrad Troutman, who's the head of engineering for Cumulus, with WXLO, plus all their engineers, plus their sales, plus their sales manager, program director, general manager. We drove around for hours in downtown Boston, turning the boosters on and off and driving back and forth between the nodes. And other than the fact that we had different static RDS on the radio, you could not tell when you went from the main to the booster. In some cases, it sounded like a little hit of multipath. That's it. It's amazing how well it works when you do it right.
Good, thank you.
Bert, there's one other question I had was you mentioned in the presentations about operating in HD. Were
Yes.
you indicating that the booster itself would operate in HD?
Yes, it is. I mean, we have it operating that way on 3 stations currently.
Is that with subchannels as well?
Yes.
Are they the same that the main channel has, or can they be separate?
Yeah, they could be separate. As I mentioned, we've got it so that going from a main to a zoned area, there's a dropout of about 1.5 seconds, which we think is fairly, unnoticeable to most listeners. And that's for the HD2 and 3 as well. So the HD2 and 3, there's some question as to whether stations would want to split those with different programming. In the case of in San Francisco, where the HDs don't meet, I think they would like to have different programming on the HD2. But the intention was not to split programming on the HDs, except obviously for the HD1, which has to follow the analog. But yes, it seems to work quite well once we got some of the mostly transport issues squared away.
Well, sort of as a follow-up on that, does the HD2 and HD3, are they restricted to the 3-minute rule as well, or can they be totally separate?
I don't think the commission cares on the HD2 and 3. At least that's the indication we've gotten. I think they were kind of like, well, do whatever you want on the HD2 and 3. I mean, obviously the HD1 has to follow, but they said the same thing about the RDS. We've actually experimented with doing zoned RDS on our max casting system for WXLO, so that an advertiser could have, say, a different RDS message in one part of town than it does on another part of town. And WXLO's actually made a few bucks doing that.
Well, the reason I bring this up, I was at a meeting a while back and the subject came up about zone casting, and they said, oh, that's really great. We can actually do one ball game on the main channel and a second ball game on the booster. And I said, no, you're limited to the amount of time on the main channel. However, if the HD2 or 3 is not limited, they could actually do separate programming, if I understand it correctly.
Yeah, I think that's probably true. I mean, I don't want to speak out of line. I think we'd want to get an official opinion from the staff, but I believe that at least the indication we got originally was that, that they don't care what you do on the HD2 and 3.
So that being said, that actually opens up revenue streams to help recoup the cost of the whole system.
Yeah. I mean, well, for zone casting, one of the models that we're working on is a revenue share, where the station actually doesn't pay anything for the equipment, and just there's a revenue share to cover the cost of the system, which includes max casting 95% of the time and 5% zone casting, which pays for the system. with a revenue share. So you still make more money, and you wind up getting the hardware for free, essentially.
Here's another couple of questions came in. We'll answer real quick. Like for zone casting, what does the studio side of program delivery look like? I guess it would be a separate automation system or something.
For zone casting, what we're typically doing, the model that we're using is using Wide Orbit's leader follower software, which they have operating in Europe primarily, where you have regional stations with the same programming and they split away and do different local programming depending on what region it's in. That's been operational for years. They've got some kind of patent on it. That's the ideal way. You could also use the same kind of split that you have for the audio streaming. Some stations have different commercials on their stream, so you could probably do something like that. The design that I'm working on in San Jose, we're going to have 2 audio processors at the studio. One would run the audio for just the zone audio, and the other would run the main. And then you'd have, when the split came up, you'd have a composite switch that would switch between the main and the zone and route the audio to the appropriate IP link and then out to the field. And then there'd be that we have some signaling to the transmitters to turn certain ones on and off. And that's just a contact closure that rides along with it.
As a final note here, a final question is just sort of clarify the difference in a booster and a translator. A lot of people, especially down in the South and the East, that never heard of boosters. Just sort of touch on that briefly.
Yeah, sure. A booster, the difference between a booster and a translator is that a booster is on the same exact frequency as the main, and it's inside the protected contour of the main. So any interference is limited to, any potential interference is limited to the same interference that the main would cause, because you can't exceed the contour, and you have to show that your first adjacent interfering contour doesn't extend beyond that of the main. So so the difference between that and a booster is obviously the booster can be on virtually any frequency, inside or outside the protected contour, and it's a separate radio station that could cause interference to other stations, other boosters, because it's not on the same frequency as the main. Does that make sense? Or
Yeah, you're talking about the translators are on a separate frequency.
yeah, translators are separate
Yeah.
frequency. I'm sorry, I get them. My brain scrambles them sometimes too. I know what I'm thinking anyway.
Any other questions from you, John? Oh, he's muted again, I think.
Yep, I'm muted again. None from me. I really appreciate Bert being with us today.
Okay, yeah, we
folks.
appreciate it. And if you have any questions, we can post his information, contact information on the website, and that way you can contact him to go directly to him. We want to remind you again of our information that's coming up. Of our next webinar will be on February the 16th. And that will actually be, let me see if I can get back to that slide, and we'll, right here, John Melt will be with us. He's with Imagine Communication, and he will be discussing all the different aspects of ST2110, primarily for television engineers, but I'm sure that radio people will get some good information as well. I've watched some of his webinars and seminars, and the audio portion that he talks about is very good. So make sure that you make a note in your calendar. Then on March 16th, we'll have the audio production webinar, and we're going to try to get as many of the production people from radio and television stations to be on the call, because he has some really good information about that. So with that, we will end our webinar series today. We thank everybody for joining, and we'll see you on February 16th.
Thanks a lot, folks.
Thank you.